So we have three major new updates about 3i Atlas, and honestly, each one seems more impossible than the last. First, Harvard scientist Avi Loeb just released calculations showing the weird sunward tail seems to actually be thousands of fragments traveling together in a swarm. Second, new observations revealed the object is pulsing every 16 hours, but the source of that pulsing is supposedly completely wrong for a natural comet. And third, new scientific data just revealed that 3i Atlas is releasing different chemicals from opposite sides, like it has two completely different surfaces. So in this video, I'll break down what is actually happening with 3i Atlas. But before we talk about the pulsing and the chemical anomalies, let's first cover Loeb's latest calculations. So as you probably know, 3i Atlas has this tail that points toward the sun. We call this an anti-tail, and we've been seeing it around 3i Atlas for months now. Anti-tails have been observed in a few comets. For example, Comet Arend-Roland in 1957 and Comet Hale-Bopp in 1997. So this is not completely new, but in those previous cases we figured out the anti-tails were optical illusions, because when scientists observed them from different angles or at different times in their orbit, the geometry changed and the tails revealed to be actually pointing away from the sun as expected. But with 3i Atlas we've been watching this structure for months at different viewing geometries and different phases of the orbit, but the structure stays there. And that persistent stability across so many observations is much harder to explain. So what could actually create this structure pointing toward the sun? Well, different scientists have different possible explanations, and they are very different from each other. The first explanation is that this could still be a viewing geometry effect due to unusually large dust particles. Here's how this would work. Normal comet dust is tiny particles, smaller than grains of sand. Solar wind blows these tiny particles away from the sun easily. But if the dust particles are much larger and heavier, they move more slowly. Large, slow-moving dust particles can create unusual tail shapes that, depending on exactly where we are looking from Earth, can appear to point sunward, even though they are actually being pushed away. It is all about the angle and the timing. This has been observed in a few other comets before, so it is a known natural phenomenon. Most astronomers think this is probably what we're seeing with 3i Atlas, but Harvard scientist Avi Loeb says that for this explanation to work, the object must be way bigger than what observations have shown it to be, which is around 3 miles in diameter. So Loeb has proposed a completely different mathematical explanation. And this one is based on precise orbital mechanics that we can calculate and test. So you probably know that 3i Atlas is showing non-gravitational acceleration. The object is not following a pure gravitational path. Something is giving it a small extra push. This push usually comes from particles jetting off the surface. That happens when gas shoots out in one direction, and it creates a tiny rocket effect that nudges the object in the opposite direction. This is normal for active comets. We see it all the time. But here's where Loeb's hypothesis gets interesting. What if it is surrounded by a cloud of smaller fragments or debris? These fragments would be traveling through space alongside 3i Atlas at roughly the same speed. But here is the key point. If these fragments are not producing jets themselves, they would be following pure gravity, no extra push. Just the sun pulling on them. Now think about what happens over time. 3i Atlas is getting nudged slightly away from the sun by its jets. The fragments are not. They are just following gravity, which pulls them toward the sun. Even though this difference is tiny, over the vast distances involved in space travel, it adds up. Loeb calculated exactly how much separation this would create. At 3i Atlas's current distance from the Sun, which is about 160 million miles, the offset between the main object and a cloud of fragments would be about 33,500 miles. When viewed from Earth, this separation would appear as about 0.7 arc-minutes of angular separation. That is a very specific prediction. And what's interesting is that the November images do show a sunward glow measuring close to 0. 7 arc-minutes. So the math matches the observation. Now Loeb points out something else that makes this theory compelling. If there is a fragment cloud, its combined surface area could be much larger than the main nucleus. Imagine 1 trillion tiny fragments. Together they weigh just 1,000th of 3I Atlas's total mass, but because they are broken into so many small pieces, they would have 100 times more total surface area exposed to the sun compared to a single solid object of the same mass. Now, why does surface area matter? Because that is what determines how much ice can sublimate when heated by the sun. More surface area means more ice turning into gas all at once. More gas means brighter appearance, which means more visible tails and jets. This could explain several puzzles that have been bothering astronomers, like why 3I Atlas appears so bright for its estimated size, why calculations suggest it is losing more mass than it should physically be able to if it were one solid intact object, and why the jets stay so straight and collimated instead of getting smeared out by the rotation. Now, this swarm hypothesis is just that, a hypothesis. It has not been confirmed. Most scientists think the viewing geometry explanation with large dust particles is more likely. That is a known natural process, but the November 11th images showed the nucleus still appears to be intact. They specifically looked for signs of fragmentation using multiple image processing techniques and found nothing. So if fragments exist, they would have to be very small. Now, before we dive into the unbelievable chemical anomaly, let's talk about the second strange behavior scientists are tracking. This one shows the most precise periodic pattern ever measured in a comet, because scientists have been tracking how 3I Atlas's brightness changes over time, and the object gets brighter in a perfect rhythm every 16 hours, like clockwork. At first, astronomers thought this was just the object spinning. But when they looked closer at the data, they realized the brightness changes are way too large to come from rotation alone. Less than 10% of the light we see is coming from the solid nucleus. More than 90% is coming from the coma. If gas is flowing out at 980 miles per hour, then during one 16-hour cycle, that material travels about 15,900 miles before the next cycle starts. And this distance matches what observers are seeing in the images. The coma appears to be pumping up and down in brightness. Now, have we seen periodic brightness variations like this before? Actually, yes. Comet Halley showed brightness variations with a 7 to 8 day period. Comet C 2013 A1 Siding Spring had an 8-hour cycle, and Comet 2P Encke showed an 11-hour period. So, periodic pulsing from rotation is actually pretty common in comets. But here's what makes 3I Atlas different. In those comets, the brightness changes came from the shape of the spinning nucleus. Different parts of the surface have different brightness. So as it rotates, we see variations. But with 3I Atlas, the coma itself is actively pumping up and down with each rotation cycle. The amplitude of these variations is also unusually large, at tens of percent, which suggests very strong periodic outgassing. So what could explain this behavior? Well, the most likely natural explanation is thermal cycling from an active ice region. 3I Atlas probably has a large pocket of ice on one side of the nucleus. As the object rotates, this ice pocket faces the sun once every 16 hours. Solar heat causes the ice to sublimate rapidly and shoot out a burst of gas. Then the pocket rotates away from the sun and the gas flow slows down. 16 hours later, the pocket faces the sun again and another burst shoots out. This creates the pattern where the coma gets filled with fresh gas and dust every rotation, then fades, then fills up again. Now, Harvard scientist Avi Loeb has pointed out there is a way to test if this natural explanation is correct. If solar heating is driving the pulses, then the bright jet must always point toward the sun when it pulses. That is the only direction where solar energy can heat the ice. Loeb also notes that if the jet points in directions that have nothing to do with the sun position, that would be harder to explain naturally. He has suggested that could indicate something else is creating the pulses. But right now, most scientists think the thermal cycling explanation fits the observations well. So, astronomers have been trying for months to figure out what 3I Atlas is actually made of and what chemicals are coming off of it. Well, the data just came back from the ALMA radio telescope, and this thing detects the exact molecules floating in space. ALMA found two specific chemicals coming from 3I Atlas, methanol and hydrogen cyanide. Now, finding these two molecules in space is totally normal. Methanol and hydrogen cyanide are common chemicals in comets. We expect to find them. But the first part of what's weird about this is the ratio. ALMA just revealed that at first the ratio was 124 to 1. 3 days later, it was 79 to 1. Now here's why that's absolutely wild. In normal comets, the methanol to hydrogen cyanide ratio sits around 10 to 1, maybe 20 to 1 at most. Out of thousands of comets scientists have studied, only one has ever shown a ratio this extreme. A comet called C2016 R2 Pan-STARRS. That thing had a ratio around 100 to 1, and scientists consider it a total freak of nature. They still have no idea why its chemistry was so weird, and now 3I Atlas is showing the similar unusual ratio, except C2016 R2 formed in our solar system. 3I Atlas formed in a completely different star system light years away. So we have two objects with freakish chemistry, and they both somehow ended up with nearly identical ratios despite forming in totally different parts of the galaxy. But ALMA did not just measure how much of each chemical there is, it actually found where on the comet these molecules are coming from. And this is where everything gets really weird. Methanol is concentrated on the sunward hemisphere, so the side of the comet facing the sun is blasting out methanol at way higher rates than the other side. But the hydrogen cyanide is doing the exact opposite. It is concentrated on the side pointing away from the sun. So we're not looking at a uniform ball of ice that is the same all the way through. This is an object where one half has completely different ice composition than the other half. It's like someone took two totally different comets and glued them together. This is the first time scientists observe an object from another star system in enough detail to see this kind of chemical separation. Now, we have seen some solar system comets with active regions on different parts of the surface, but those are just pockets of ice that happen to face the sun at certain times during a comet's rotation. 3I Atlas is different. This is an entire hemisphere showing one chemistry and the opposite hemisphere showing completely different chemistry. So there's two possible explanations for this chemical anomaly. The first theory is that 3I Atlas formed in a region of its home solar system where different types of ice were layering on top of each other. So maybe one side has peeled off more layers as it's been traveling for billions of years. But this explanation makes no sense, because comets are constantly spinning as they're flying through space. The second possible explanation is that cosmic rays are the reason for this anomaly. Cosmic rays are tiny particles constantly flying through interstellar space. Maybe those particles hit one side more than the other and change the chemistry. But again, that would require the object to maintain the same orientation for an extremely long time, which is basically impossible, because 3I Atlas makes a full spin every 16 hours. So as of right now, no scientist has come out and explained this anomaly. And even though I disagree with Harvard scientist Avi Loeb's theory about this object being technological, I actually respect him a lot for being probably the only one who's actively trying to explore the anomalies of 3I Atlas. So let's put all three of these updates together and see what they tell us. First, the sunward tail. Loeb's calculations suggest it could be a swarm of thousands or even trillions of tiny fragments that separated from the main nucleus. His prediction of a 0.7 arc-minute separation matches the observations perfectly. If this is correct, it means 3I Atlas shed a massive amount of material during its close pass by the Sun. Not a catastrophic breakup, but a controlled shedding of fragments that are now traveling ahead of the nucleus. Second, the 16-hour heartbeat. The object pulses with machine-like precision. The coma pumps up and down every 16 hours as gas and dust are released in regular bursts. The natural explanation is thermal cycling, an ice patch rotating in and out of sunlight. But the amplitude is unusually large, and the precision is remarkable for an object that's been tumbling through space for billions of years. Third, the chemical anomaly. Methanol on one hemisphere, hydrogen cyanide on the opposite hemisphere, a ratio that's 5 to 10 times higher than normal comets. And no good explanation for how this separation could exist on a rapidly rotating object. Each of these anomalies, taken individually, could potentially be explained by natural processes, maybe with some creative thinking and new models. But when you put them all together, the fragment swarm, the precise pulsing, the chemical separation, the picture becomes much more puzzling. This is an object that's doing multiple things that shouldn't be possible, and it's doing them all at the same time. Now, I still think 3I Atlas is natural. I think it's a comet, but it's a comet unlike any we've ever studied before, because it's from another star system. It formed under different conditions. It's been shaped by different processes, and that's what makes it so valuable. It's teaching us that our models of how comets work are incomplete, that there are processes and structures we haven't encountered in solar system comets. So here's where we are. 3 major updates about 3I Atlas, and each one is more mind-blowing than the last. Avi Loeb's calculations show the sunward tail could be a swarm of fragments, and his prediction matches the observations with stunning precision. The 16-hour heartbeat shows the object pulsing like a machine, with the coma pumping up and down in perfect rhythm. And the ALMA data reveals a chemical anomaly that no one can explain. 2 different hemispheres with completely different compositions. Scientists are scrambling to understand how all of this is possible. How can fragments separate and travel in a swarm? How can an ancient tumbling comet maintain such precise rotation? How can chemicals be separated by hemisphere on a rapidly spinning object? These are the questions that will drive research over the coming months. More observations are being made, more data is being analyzed, and maybe we'll finally understand what makes 3I Atlas so special. But for now, we're left with an object that's breaking all the rules, an interstellar visitor that's teaching us the universe is far stranger than we imagined. This comet is 7 to 10 billion years old. It's traveled through interstellar space for millions of years. It's encountered 93 different stars, and now it's here, showing us things we've never seen before. And that's what makes these updates so insane, because every answer leads to more questions. Every observation reveals new mysteries. If you watch to the end, drop me a like and subscribe for more updates. If you want to learn more about the other interstellar visitors that have passed through our solar system, check out this video where I break down the mystery of Oumuamua and whether it could be artificial. Thanks for watching, and I'll see you in the next one.